Have you felt that you can stay up later and later, as if the length of a day is increasing? This might not be entirely your imagination. Scientists confirm that our day is indeed lengthening, unnoticeable to the naked eye. And the mastermind behind all of this is actually related to the moon above our heads. Since humans installed retroreflectors on the moon, decades of laser measurements have led scientists to conclude that the moon is escaping Earth at a speed of 3.8 centimeters per year. So the question arises, what is the relationship between the moon's escape and the length of our day? Who gave it the courage to run away? And will the moon really fly away completely? Today, let's deeply explore this grand mystery concerning the evolution of Earth civilization. To solve this mystery, we must first find the mastermind. Is the first suspect you thought of the sun? Suspecting that its huge gravity is interfering. After all, the sun's gravitational pull on the moon is more than twice that of the Earth's. But why hasn't the moon been snatched away over 4.5 billion years? The reason is that the Earth-Moon system is a gravitational hole. The sun's gravity acts more like pushing this whole system rather than tugging the moon away separately. So the sun could be excluded as a suspect. If it is a hole bound by gravity, why is it still separating? This leads to the second suspect, the mysterious forces of the Milky Way, such as those related to dark matter. Although it sounds interesting, currently we cannot find any direct evidence. This conjecture is more like science fiction. Lack of evidence means the case cannot be resolved currently. When all clues seem to point toward cosmic space-time, scientists discovered the true driver in an unexpected place. Right under our feet, the Earth, or more accurately, Earth's oceans. We previously said the Earth-Moon system is a gravitational hole, and now we say the Earth itself is the driver. This sounds somewhat counterintuitive. Behind this is the most fundamental law of the universe: conservation of angular momentum. We can use the analogy of a figure skater. When the skater extends their arms, their rotation slows down. When they pull their arms in, the rotation speeds up rapidly. The Earth-Moon system is such a massive cosmic figure skater. Earth is the body. The moon is the extended arm. The moon uses its gravity to pull on the Earth's seawater, forming the tidal bulges we see every day. However, Earth's rotation speed is too fast, completing one day in about 24 hours. The moon takes about 27.3 days to orbit the Earth. This results in a peculiar outcome. The tidal bulge, pulled up by the moon, is always carried slightly ahead of the moon by the rapidly rotating Earth. This leading tidal bulge itself has mass and gravity. It acts like a gravitational anchor, constantly pulling on the moon's coattails, gently accelerating the moon. Energy is not created from thin air. This accelerating energy is actually stolen from the Earth's rotational kinetic energy. Now, let's return to the figure skater analogy. Due to tidal friction, Earth's rotation slows down, equivalent to the skater's body spinning slower. According to the conservation of angular momentum, to keep the system's total angular momentum unchanged, the extended arm, the moon, must move faster and farther away from the body. This is the physical essence of the moon's escape. The first layer of the mystery has been unveiled. The mysterious driver is the Earth itself. But Earth has paid a huge price because its most precious possession was stolen. This cosmic-level energy transfer is never unidirectional. Simply put, what is being taken is not just the distance between them. It is quietly stealing the most precious thing from Earth, time. How we know this? We must mention the definitive evidence. 50 years ago, Apollo astronauts left several special mirrors on the moon called laser-ranging retroreflectors. For decades, observatories worldwide have daily aimed powerful lasers at these mirrors and precisely calculated the time the light returns. It is through this millimeter-level precise measurement that we confirm, with irrefutable evidence, that the Earth-Moon distance increases by 3.8 centimeters per year. It doesn't sound like much, right? But the direct cost of this distance increase is the deceleration of Earth's rotation. Our day lengthens by about 1.7 milliseconds every 100 years. Although this small number seems negligible, it can reshape things over long geological eras, like dripping water eroding a stone. For instance, during the Cretaceous period when dinosaurs reigned. By analyzing the growth rings on ancient seashell fossils, scientists deduced that a year then had about 372 days, and each day was only 23.5 hours long. Going further back, to the Devonian period 400 million years ago, a year even had 400 days, and each day was only 22 hours long. The time the moon stole over billions of years has shaped our familiar 24-hour cycle. This grand cosmic scale change reminds us to truly cherish the current day-night cycle regulated by the moon. In the time before sleep at the end of the day, instead of letting the phone screen stimulate your eyes, why not switch to a more relaxing method, such as activating the listening mode in the Soda Music app? It supports screen-locked playback and scheduled shutdown, allowing you to peacefully fall asleep while contemplating the mysteries of the universe, as if slowing down together with Earth's rotation. Of course, subtle changes in the timescale are merely the mild continuation of this cosmic drama. If the moon truly leaves us, time is a small concern. What is worse is the removal of the entire planet's stabilizer. Based on model predictions, we get several possible scenarios. The first scene is the collapse of coastlines. First, Earth's tides will drastically weaken. The moon's gravity contributes 2/3 of the tidal force, while the sun accounts for only 1/3. Losing the moon means the tide height will drop by over 70%. What does this mean? The hundreds of millions of kilometers of intertidal zones worldwide, heralded as the gene pool of marine species, will completely disappear. Countless species that have survived for millions of years relying on tidal rhythms, such as shorebirds foraging on tidal flats, crabs breeding in the tidewater, and shellfish resting between rocks. Their survival patterns will be instantly destroyed, leading to an unprecedented mass extinction. The second scene is Earth's senile dementia. The moon is the stabilizing force for Earth's axis of rotation. Currently, Earth's tilt is firmly stabilized by the moon's gravity, oscillating within a small range between 22.1 and 24.5 degrees. This stable tilt is what creates our mild and regular seasons. Once the moon is lost and this stabilizer disappears, Earth's axis of rotation will begin to swing violently and erratically. According to scientists' latest simulation research, the amplitude of the swing could be around 10 to 40 degrees. Imagine today's equator tens of thousands of years later might become the ice-covered North Pole. Some scientists speculate that ice ages and global superheat waves would switch randomly, like a game of Russian roulette. Surface ice sheets would repeatedly melt and freeze, and sea levels would wildly rise and fall by hundreds of meters. On such a planet, no form of agricultural civilization could exist. The third scene is the regression of life evolution. Some scientists propose a chilling conjecture. The fact that we can stand here and ponder this question is thanks to the moon. For 0.5 billion years ago, the newly formed moon might have been only 1/10 of its current distance from Earth, just over 20,000 kilometers. At that time, the tides it triggered on Earth might have been 1,000 times higher than today, with huge waves reaching hundreds of meters, repeatedly washing over the primitive continents every day. It is precisely this immensely powerful, destructive force that may have repeatedly brought organic molecules and primitive life, initially born in the deep ocean, to the shore. The alternation of wet and dry conditions catalyzed the formation of more complex life forms, eventually forcing them to move onto land. If this primitive engine of evolution were lost, Earth might still be a silent water sphere covered by oceans. The fourth scene is the dark ages of humanity. Imagine that the night sky would forever lose its brightest star. Nighttime brightness would sharply decrease by over 90%, leaving only pitch blackness. All our traditional calendars, such as the lunar calendar, would completely fail. Human poetry, art, myths accumulated over thousands of years, and even the tradition of admiring the moon during the Mid-Autumn Festival would require everyone to own a telescope. This would cause the cultural and spiritual world to lose an eternal reference point. Now, let's return to the ultimate question. Will the moon completely disappear? The answer is no, but the eventual outcome might be stranger than disappearing completely. Because there's an ultimate rule in this cosmic tug-of-war. When the Earth's rotation, stolen by the moon, becomes perfectly synchronous with the moon's orbital period, this billion-year escape will automatically cease. By then, the tidal bulge will no longer run ahead of the moon, but will be directly beneath it. The effect of gravitational acceleration will then disappear. In that incredibly distant future, calculations show that Earth's day will last over 1,100 hours, equivalent to about 47 current days. At that time, the moon's orbit around Earth will also take exactly 47 days. Earth will have only one fixed side, perpetually facing the moon. They will stare at each other in the void, perhaps exchanging the lines, "What are you looking at?" "Looking at you because I miss you." This accompaniment, lasting tens of billions of years, will conclude with an eternal gaze, neither able to see the other's far side. Of course, we don't need to worry about this ending, because according to stellar evolution models, in about 5 billion years, our sun will run out of fuel and enter the red giant phase. Its volume will expand to swallow Mercury and Venus, and possibly even affect Earth. The moon's escape is merely a tragic yet beautiful interlude before the universe's true finale. Therefore, the slow departure of the moon is the most profound lesson the universe teaches us on its grandest scale. All stability and beauty in this world are merely a dynamic, fragile balance. Precisely because we know separation is inevitable, every mid-autumn reunion seems so precious and important. This mid-autumn festival, when you and your family look up again at that bright moon, you will know that what you see is not just a poem or a painting, but rather a cosmic dance lasting 4.5 billion years, grand, solitary, and incredibly precise. And we are the luckiest witnesses of this dance.